If there's anyone who doesn't need an introduction here, it's Yehuda. He's pretty much in the core team of every project I care about, or has been at one time. Yehuda kept wondering what he should do a talk about because there's so many things you can talk about. So this talk idea is actually something that Sarah May and I came up with, and Yehuda was like, oh, that sounds like fun. So I present to you Yehuda Katz with A Tale of Two MVCs.
Thank you. Am I on? Looks like I am not mirrored after all those technical difficulties. What is going on? Okay. Seems good. Present. Boom. All right. So what I'm going to be talking about today is MVC broadly, GUI programming. I apologize in advance if this ends up being dry. I'm doing my best to avoid that, but I think I will fail. So just a warning ahead of time, this talk is an attempt to unpack what people mean when they say MVC, what people mean when they say GUI, and as a result of that, there's a lot of technical detail. Hopefully people will find that useful or interesting. Other than Sarah May and Josh asking me to give this talk, one of the motivations for me giving this talk was this quote from DHH: current JavaScript solutions suffer from double MVC. You need both server and client-side MVC stacks. The thing that frustrates me about this quote, and many other people who know anything about MVC, is that the amount of unpacking that you have to do on that sentence just to get to a point where you can even understand it is significant. And once you've done that, you realize that the entire sentence is pretty nonsensical. And because of the fact that it says the word MVC twice, but they mean different things in the different contexts, unless you're doing it really, really poorly, which I'll get to later. So the point is, I looked at this and I realized the fact that it resonated with a lot of people. I think a lot of people looked at this and said, yes, that sounds right. It resonated, meant that people don't really have a good understanding of what the Rails model of GUI programming is and what the Ember model is, what the backbone model is, what the Smalltalk model was. I see a lot of people referencing the Smalltalk model, but not really providing a lot of value in those discussions. So I wanted to unpack what it is to do GUI programming and then how these different models work. So the first thing is I don't want to talk about MVC at all because MVC is kind of a meaningless term. What I want to do is I want to present a unified model of GUI programming that I think can be used to understand pretty much all these different systems, so we can look at what these different systems, how these different systems are handling each part of this. And I think to understand GUI programming, there's a bunch of steps. Step one is you have come into the system for the very first time. The user wants to look at a screen. You're going to have to bootstrap whatever objects you have, and you're going to have to put them into the state that will be useful in the future. Once you've done that, you need to take those objects and use them to draw the initial UI. And maybe bootstrap objects, if you're doing a very, very simple, global, state everywhere kind of thing, is very small. But I think as the systems get more complicated, bootstrap objects becomes a more complicated thing. Then you draw your initial UI, you put it on the screen. As the user starts clicking around, what you want to do is you want to take the thing that the user actually did, which is like mouse down at position 12,57, and convert that into user intent. This becomes especially important when you, for example, want to support touches and clicks and maybe keyboard events all meaning the same thing. You really do want to have a part of the system that says, okay, the user touched position 1215, the user was focused on it, hit enter, the user tapped it. All these things you want to have be converted into a single meaning. Then the next thing you want to do is you say, okay, the user clicked log out. I would like to log the user out, so I'm going to update the application state. So there's the notion of application state. This is not necessarily persisted anywhere. It's just stuff that happens to be what the application is doing right now. Then there's update domain object. So if I delete a to-do, I want to actually remove it from the system. Once I've done those things, so I want to do those things first, then I want to say, okay, hey UI, just FYI, there's some new stuff for you to draw. And then something in the system needs to take the fact that there's something new to draw and draw it. So I think those are basically all the things that happen no matter whether you're using MVC, MVVM, MVP, Smalltalk MVC, Rails MVC, Django MVC, Ember, Backbone. All these systems have places for each of these states, so I want us to be thinking about the whole story in terms of these things. So I think the first attempt that people had in the 70s and then again in the 2000s in web was to do everything manual. And I think the easiest way for us to understand this is jQuery. And what I mean by all manual is, okay, so bootstrapping objects, no problem. I'll do that when the DOM becomes ready. Draw initial UI, no problem, DOM ready. I want to translate some raw input into user intent, I'll just do that in an event handler. Update application state, I'll do it in an event handler. And the application state will just be on the just be global variables. How do I update domain objects? Again, event handlers. Now, how do I save them? Just some AJAX thing in an event handler, persistent ad hoc. How do I notify my UI of changes? I don't have to notify anything, I just do everything in my event handler. I want to update UI, event handler, right? And I think this works really well for extremely simple things. This is basically where the GUI programming was in the 70s, and it also is where GUI programming was in 2005. So yes, there was some weird gap there. Now, in the 80s and like in 2008 or something, you can see there's parallel timelines here, people realized that it was a bad idea to have your view logic, the logic that's drawing things, and the logic that deals with domain objects be in the same place. So the concept of separated presentation was created. And I think the two easiest ways to understand this are Backbone programming. How many people have used Backbone? A lot of people, awesome. And Smalltalk, I think probably many fewer people have written Smalltalk 80 MVC. So I'm just going to stick with Backbone for the moment. And here is basically what it looks like. You have a UI, so the UI is like a graphics context. The UI has raw input. The view basically takes the raw input, figures out what to do with the raw input, updates the model. The model then notifies the view, and importantly, this is a observer relationship, so the model doesn't know anything about the view, it's just notifying the view. And then the view says, oh, I can see the model changes, I'm going to go update the UI. So this is the Backbone model. It's quite simple, quite straightforward, and it's what I will call separated presentation for the purpose of this talk, separating the presentation and the model. Importantly, like I said, the view has access to the model does not have access to the view. But obviously, the model has to notify the view somehow, so there's another system called observers. Again, Backbone has a system that we use to update the view. Now, separated presentation actually is quite a lot like MVC. In fact, this concept of separated presentation came out of MVC. There's just a little small tweak. And the small tweak is that this is separated presentation. We have a view and a model. MVC basically just says, I would like the raw input to go to one object, the controller, and the drawing to happen in the view. So previously we had one object, Backbone does this, that is responsible for both receiving events and also updating the UI. In MVC, there's a controller object that takes in the raw input, and the view draws. Importantly, in Smalltalk MVC, the view and the controller actually have access to each other as instance variables on themselves. And this is heavily used in practice because the observer pattern doesn't really work for more complicated situations. So as a practical matter, the separated presentation model, where they're one object, and the MVC model are roughly equivalent except for code organization, right? So you put code that has to do with updating the UI in the view, and you put the code that has to do with receiving events in the controller, but because they have access to each other, they end up being coupled anyway, so we basically talking about the same thing. And this is what we mean when people say Smalltalk 80 MVC, just this thing. So let's go look at what is happening now when we talk about MVC. So first of all, how do we get objects into the system in the first place? MVC actually does not tell us the answer to that question. MVC says, you bootstrap objects, however you bootstrap objects, that's not my problem. That's some other pattern's problem. Who draws the initial UI? The view. Who translates raw input into user intent? The controller. And you're going to see a pattern here with MVC. The next four things are controller, right? Update application state, the controller. Update domain objects, the controller. Notify UI of changes, either observers if you're lucky and it's very simple, or the controller. And then update the UI, the view. So we basically have a few objects, but the controller is doing a lot of stuff. The controller is doing many, many things. Also important to note, application state and domain objects are being managed by ad hoc objects that are not, there is no clear answer in the system for how they're supposed to work. So people obviously build patterns. When you write Backbone code or you write Smalltalk code, you come up with patterns that help you to organize this, but the actual MVC pattern itself does not tell you how to solve, where to put your application state or where to put your domain objects. So what problems do we have here? There's basically, in my view, three very important problems with the original MVC pattern. Very importantly, bootstrapping. How do you actually get the objects in the first place? Now, you can create patterns, but I think many people create different patterns for how you actually bootstrap when you go into a particular screen. Hierarchy. So actually, Smalltalk MVC ended up developing really good patterns backbone, much less so. But it really is important. Hierarchy in UI is a very important thing that comes out of even very simple UIs, and not having a pattern just baked into the, not having a thing baked into the core pattern basically means that there's going to be a lot of different ways that people manage hierarchy, and it's going to be hard to build additional abstractions on top of that hierarchy, which we're going to get to later on. And finally, application state itself is just stored anywhere in these systems. So again, you could probably create an object that manages it, and you can tell people to use that. But the actual MVC system is really every MVC, every widget has its own MVC, and that's basically the end of the story from the perspective of the MVC pattern. Okay, so that's all UI, and now obviously I'm here to talk a lot about Rails, and I think an important starting point for this discussion is that a lot of people say Rails has nothing to do with MVC. It's a completely different pattern. Stop talking about Rails as MVC. So again, I don't really care about whether we use the term MVC or not. That doesn't matter to me at all. But I do want to make clear that Rails is a GUI design pattern that has a lot in common with the other GUI design patterns that we're going to talk about today. So here's basically how I would draw. I am missing some arrows around the view. I am sorry about that. Here's how I would draw it. So we have a browser, and the browser for our purposes from the perspective of the simple Rails pattern is a total black box. And what we do is the view, there should be an arrow. The view basically gives the browser some HTML. The browser goes and puts it on the UI context. When the user clicks on something, the browser takes that raw input information and says, oh, the user clicked on a link. Therefore, it's an event that says transition to this other place. The user clicked on a button in a form. The user hit enter in a form. That's a form submission, right? So the logic that says how you convert a raw user event into a semantic event, the browser is doing. But importantly, the browser is doing it based on a bunch of pre-computation that we did ahead of time. So when we rendered the UI in the first place, we figured out what every single thing that the user could possibly do on the page would be and what it should mean. And we embedded information about what those things mean into the markup. So that basically as a mechanism of convincing the browser to convert the user's raw input events into something that we understand, right? So we don't have an opportunity in the Rails model of intercepting user events and figuring out what they mean. We have to do that ahead of time using markup. And importantly, once the browser does figure out what it means, the browser can't immediately update anything. The browser basically does the same thing as the previous patterns. It sends the event, but it has to send the event over HTTP. So it basically packages up that transition request, that form submission into a HTTP request, sends it to the server. The server basically picks it up in the controller. The controller updates the model. There should be arrows by the view, basically double up and down arrows. The controller goes into the view, gets new stuff, and then sends UI back to the browser, and then the browser will redraw the entire thing, right? So that's basically what's happening. I think the important thing that I want you to realize here is that this is totally a UI pattern where you have some raw, it's totally a UI pattern, just like everything else before, but there's just there's some weird quirks here that are forcing us to both pre-compute the semantic meaning of every single possible user event, and also we're limited to a few things that the browser knows how to do, and transmission of the event over HTTP and full page refresh. So that's basically what's happening. But otherwise, it's a pretty normal UI pattern. And I think if you think about it, you've probably used applications where you click a little checkbox and the entire page reloads. Usually these things are written using Java. Totally a normal UI pattern. It's just that you have to go back to the server every single time you want to do any kind of refresh. So bootstrapping objects, Rails has actually done a nice thing for us. The router and the controller give us a nice place to bootstrap objects, so it's no longer sort of ad hoc. The initial UI is drawn in the view. The browser and the template translate raw input into user intent. That happens pre-computed. This is something you cannot intercede into at all. The controller basically is going to receive that request, and it's going to update application state. Again, we have a sort of nice thing here, which is that Rails says application state goes in the session. The sort of not nice thing is that application state is on the server 10,000 miles away from your, or thousands of miles away from your user. But there is a place to put it. Updating domain objects also happens in the controller, persisted via active record, and then once we have done all that work, we tell the UI, hey, there's some new stuff here over HTTP, and the browser will update the UI. So again, very similar structure in terms of how we go from initial UI, getting events, and then re-rendering UI. It's just a little bit weird how it has to be structured in terms of normal GUI patterns. So what are the problems here? There's actually a problem that's sort of unrelated to the rest of the normal things that you would think of as Rails problems, which is that Rails actually provides no mechanism for dealing with UI hierarchy at all. There's basically one big granular thing, which is the entire page, and whenever anything changes anywhere in the hierarchy, you just re-render the entire page. So there's one controller and one view, and that's basically the equivalent of like one Smalltalk MVC pair, right? But often you have more deeply nested hierarchy that you want to model, and it's somewhat tricky in Rails. Another problem is that if you reload the page all the time, things like what thing is currently focused, or like the ability to undo, these are things that are stored inside of the browser state, but the browser state and the Rails application state are thousands of miles apart and do not communicate. So you basically have to choose between updating the browser state or updating the entire page via the app, via the Rails app, and that sucks. Latency in general, even if you can get it to 50 milliseconds like DHH advocates for, that does mean that anytime you want to do anything, anytime you want to interact with the user wants to interact, you have to go make a round trip to the server. And in the normal way of doing Rails, and I'll get to later some workarounds that people use with JavaScript, but the normal way is that you have to limit the interaction patterns that the user is allowed to use to things that the browser knows how to package up into something, into semantic events. So you have to limit specifically to links and forms. So that's why when you say link to delete in Rails, it has to create a form with a link that ends up submitting a form that is a delete, right? Because you're basically limited. So Rails does some clever hacks there with JavaScript, but the bottom line is that you're limited to things that the browser knows how to package into semantic events. Now, because of the fact that being limited to a list of things that the browser knows how to package into semantic events, links and forms, is extremely annoying, a lot of people say, let's say I want to support, I want to support taking something and dragging it down. I want to support swipes. I want to support anything like this. So what a lot of people will do is they'll basically say, I'm not going to just limit myself to the list of things that the browser knows how to interpret and send back to the server. I'm going to stick some JavaScript in between, and what that JavaScript is going to do is it's going to see what the event is, and I'm going to convert that into an AJAX request that I send to the server. But still, the server's going to give me back. UI. The server's going to give me back HTML. And this is basically the turbolinks pattern, right? Where you write JavaScript code to handle events. You make XHRs, but at the end of the day, you're still limited to full page updates. I don't have what I thought I had on the next slide, but basically the bottom line here is that this works fine, but you're limited to full page updates, which means that the first three problems exist, but the bottom problem does not exist. Most notably, the latency problems, the losing the browser state problems, and the lack of hierarchy problems still exist. Okay, so great. We have now I've now sort of walked you through early on, backbone Smalltalk patterns. I've walked through the Rails pattern. Rails has been frozen in place for a number of years. So now that we've gotten to 2005 on the Rails side, let's keep going forward to like 1992, 1995, et cetera, on the GUI side. So I'm going to talk about some improvements. So far we talked about a simple MVC system. I'm going to talk about some improvements that the Smalltalk and Cocoa worlds made to the raw GUI patterns that are not reflected in Rails at all. So the first one is that there's often a situation where, so previously we just said the controller updates the model directly, and then the model notifies the view, and the view updates the UI. Great. Well, there's a little bit of a problem with that, which is that it implies that the model is capable of having all the information, all the state that it could ever need to represent. So one example of where this falls down pretty heavily is things like I want to present, so if you're just presenting a number, so your model has a number, 50, and you want to put it on the screen as 50, it's easy to just say, okay, the model will notify the view directly. The model's 50 means the same thing as the UI's 50. Awesome. Now what if you say, okay, if the number is less than 20, I want it to be red. So obviously you do not want to have the notion of red in the model, but you really have no place to actually put the translation from less than 20 into red. So what you end up doing is you end up having the controller talking directly to the view and saying, hey, I can see that the number is less than 20, so I'm going to tell you to represent this widget as red. And the thing that's bad about that is that it basically creates now a big monolithic object like we were trying to avoid in the first place. So what you would like to do is you would like to have another object which is capable of basically looking at the model, saying, okay, I can see it's less than 50. it basically creates its own attribute called color, and that attribute is basically going to control the view. And I don't want to get into a huge amount of detail, but this thing, that's a simple example. It really adds a lot of value, and a lot of Rails people have gotten into the notion of presenters for similar reasons. Basically, the ability to have an object that you can easily test that isn't all bound up in UI logic in HTML or in GUI widget land, but which still sort of knows things about the widget universe. So presentation model, its job is to separate the preparation of the view from drawing. And it retains the separation of drawing from the raw event handling that we had before in the previous MVC pattern. So examples here are convert a number into a color, store information about what row is currently selected, where should that go, and then things like, okay, I'm in the middle of typing into a new row. Obviously, I don't have a model for that yet. Where should I put that? So the text of the new row might go into this presentation model. So it's basically a place where you can put state into and not have to worry, and not have to have that be state that belongs in a domain model. Okay, so that's sort of the first enhancement, is just another slot where you can put state that doesn't belong on the view but doesn't belong in the model. Now there's one elephant in the room that I've missed, that I haven't talked about this entire time, and that elephant in the room is how you deal with things that are application-wide. So let's say logout. So the user clicks a logout button. It doesn't really make sense for a view to handle logout, nor does it make sense really in the MVC pattern for a controller that's managing a particular view to handle logout. There's really another thing. There's a higher level thing, which is I have an application controller or something like that. I have an application object, and that object is in charge of managing things that have nothing to do with a particular view. They have to do with the application's own state. So Coco sort of enhanced the previous pattern a little bit. And basically, the way Coco's pattern works, it's also a little bit simpler, is that it doesn't have this separation of view and controller that the typical MVC pattern had. Goes back to the original, where it's just one object that both handles input and draws. But there's another object in between. What this slide is doing is basically showing you that Coco adopted the presentation model pattern from the previous slide. So basically, there's UI, there's view, which is basically just collapsing the controller and the view from the VisualWorks pattern, and then Coco calls the thing that we called before the presentation model. They call it a mediating controller. So it's basically just an object that sits in the middle, like we said before. The view updates it, the mediating controller updates the model, and then there's a path through. So this is exactly the same thing as the presentation model that we showed before, but it just collapses the view into one thing. So it's just basically an acknowledgement that the controller and the view were pretty tightly coupled to begin with, so we don't need two objects there. I think also they were running out of names for things. But importantly, sometimes you're like, oh, the user has typed in some text. I would like to update the model. Great. That makes total sense for the view to send on to the mediating controller. That's very much about what is being presented on the screen. But let's say the user clicks logout. Maybe there's a logout button deeply nested down inside of some widget, inside of a widget, inside of a widget. Basically, what the controller wants to do in that, or the view wants to do in that situation, is say, I don't actually know what logout means. I know that the user clicked a button with logout, but I don't know what that means. So I'm going to send an event outside of myself. And somebody else can handle this. And basically what happens in the Coco system is that there's another kind of object called coordinated controller, which is not necessarily about a particular view. It's basically just, it has a higher calling. It's about managing an entire area of the application. And if that coordinated controller doesn't know how to handle it, what it can do is it can send the event up again. So you can basically have a chain of coordinated controllers that manage increasingly larger parts of the screen, and they're basically doing things like logout, et cetera. So it basically allows you to decouple some additional state, but most importantly, there's been this sort of elephant in the room of how you even manage this kind of state in the first place. There's a whole bunch of types. There's a whole type of state, which is logout. I'm struggling to come up with another example, but anyway, the point is there's a whole bunch of state, which is things like logout, which are application-wide and are not about a particular widget, and the view would like to be able to say, hey, let me recruit some help, and not have to deal with it itself, or basically start going and poking around with global variables. So this is basically a decoupling strategy. So let's look at this sort of diagram in terms of Coco. So objects are bootstrapped. Awesome, we finally have an answer in the coordinated controller. Initial UI is rendered using the view. The view is also responsible for just taking the raw input, the mouse down at position 12, 17 converting that into user intent. But then it immediately basically goes and says, hey, you click the logout button, let me go notify the coordinating controller for application state, or you type some text, let me notify the mediating controller. So now what you'll notice is that there's multiple different objects that are responsible for each of these things, and then the changes, UI is notified of changes either via observers, if you're lucky, or controllers. This is sort of the same old horse, and updating UI happens via the view. So we had some original problems. Bootstrapping, now totally solved. There's a little bit of a problem about what to bootstrap. There's another problem, which was hierarchy. Hierarchy is somewhat managed using the chains of coordinating controllers. Application state is managed using coordinated controllers. So let me just show you a really simple example using iTunes. So in iTunes, you have a big screen, which basically represents the entire thing, and then you have smaller and smaller screens. And if you click on, let's say you click on Hanging Gardens in the middle there, basically that Hanging Gardens UI doesn't know what it means to play a song, so it's going to send an event up that says, hey, I need to play this song right now, and then that's going to go up the hierarchy. It's going to eventually get to the top level. The top level is going to say, okay, I'm in charge of managing the whole screen. I know what it means to play a song, so I'm going to go play the song and I'm going to go tell the mediating controller that's in charge of just that little area, that I'm now playing a song. So basically that's the CoGo strategy, is that mediating controllers are in charge of a little part of the area of the screen, and coordinating controllers are in charge of larger and larger areas of UI. There's a few problems here. I told you basically the answer of a good way to organize things in CoGo, but there's a little bit of an issue, which is that we don't necessarily, that's sort of a thing you have to learn for yourself. There's limitations of the observer system that force you back into interfacing with the view directly from the controller, figuring out what you're supposed to bootstrap in the first place, and also URLs in the browser. I am running out of time fast. Okay, let me talk about Ember. So Ember actually has a diagram that looks a lot like the CoGo diagram, not surprisingly. There's a couple of changes, but the most important changes are that we do not use the terms mediating and coordinating controllers. We find those pretty confusing. The thing that CoGo called the mediating controller, we just call a controller. And then the thing that CoGo uses for coordination, we call a route. We also formalize the entire route system so that it's a state machine, instead of it just being a set of objects that you have to connect up, wire up the hierarchy manually. So basically, I said there's a bit of an issue, which is that you have all these coordinating controllers. I told you the answer, but how do you actually know what to do? In Ember, we basically do that work for you. Bootstrapping objects happen in the route. Drawing initial UI happens in the template. Template or view is responsible for dealing with clicks and drags and whatnot. The route updates application state. The controller updates domain objects. We fix the system so that everything happens with data bindings. There's no need to intercede. And the template updates UI. Let me just show you an example. I'm going to take like another minute before I run out of time here. So here we have 3 pieces of UI. Again, in CoGo, you would have to manually wire this up. In Ember, that you basically get 3 templates: an application template, a navigation template, and an albums template. And each of those templates is also backed by, each one of those things is backed by a template, but it's also backed by a route object automatically without having to wire anything up, and a controller object, which we talked about earlier. And these route objects, without having to do anything more, are automatically linked together. So if this template triggers an action, it first goes to this controller, then it goes to the route and up the chain. So basically, that's the pattern that people came to in CoGo on their own, and it's just basically baked into Ember. Now here's sort of the conclusion, the end of my story here. So we've talked about a lot of patterns, and I sort of talked about, this is the Ember pattern, right? So this is the Ember UI pattern. Now, hopefully what you should realize is that Ember handles the whole UI story. Rails is not generating HTML. It's not listening for events that are packaged up from the browser. None of that is happening. The only thing that is happening here is that Rails is handling persistence. Why is this not always working? Rails is handling persistence, which is great. Now, imagine that if someone told you, oh, by the way, MySQL happens to be implemented using MVC. You would not say, oh, my God, double MVC. I have 2 MVCs. It doesn't matter, right? It doesn't matter the fact that in a Rails app, the persistence happens to be happening through a system that is implemented using some design pattern. And that's basically the same story here. The story is, in Ember, you take all of the UI logic and you move it all into the client, which solves a lot of the issues that we talked about earlier with Rails. And the only thing that Rails is responsible for is persistence. It's important to note that the persistence can get very complicated. Like, for example, when you're Amazon, persistence includes shipping a box to somebody's house. So this is a complicated thing. It's not like it goes away and now all you need is parse. but it does mean that that Rails is not responsible for UI. So DHH said current JavaScript solutions suffer from double MVC. I think the takeaway for me is this client side. There's only one MVC in a system that is sane, and that MVC is either on the client, which is basically what people do with Ember or Backbone, or it's on the server, which is what people do with Rails. This is if people are being sane. The only time you get double MVC is if you say, oh, I kind of want to use Rails, and then I also want to use Backbone to layer on top of Rails. So sometimes you're updating UI through Backbone or raw JavaScript, and sometimes you're updating UI by rendering templates. In that situation, you absolutely do have double MVC, but that's exactly the thing that DHH is advocating for. So normally you do not have double MVC. All right. Thank you very much.